Hello, and thank you for joining us today as we introduce the new features available in Pointwise version 17.1. My name is Carolyn Deere Weber. I'm the manager of the Support and Consulting Group here at Pointwise. With me today is Eric Gant, an engineering specialist in our support group. Today, as we go through the webinar, we're going to be going over the new features available in 17.1. And you can see a list of them here. As we go through this webinar, I encourage you, if you want to go ahead and start entering your questions in the questions panel and go to webinar. And after the webinar is over, Eric Gant will be happy to answer those questions. So to get started, let's just take a quick look at this list. As you can see, we're going to be talking today about everything from the new accelerators that we have available in Pointwise to our advancing front surface mesher, all the way to our new CAE solver features. So let's go ahead and get started by looking at the new accelerators. Now, as you look at this table of our new accelerators, you can see that we have over 20 new accelerators available. We added these accelerators based on customer requests and also based on features that we felt were very commonly used in our software. As an example, if you look at the top of the table, you'll see the distribute and the dimension accelerators. These two accelerators will actually open the distribute and dimension panels so you can access all the functions for these two features. Additionally, we have accelerators for commands such as join, split, and project, which are used heavily during a meshing project. We also have accelerators for the show commands, which might not be quite as well known as the others, but are also very powerful features that can help out with your productivity. As an example, if you look at the accelerators we have here, we have them for show domains, show connectors, show nodes. We also have accelerators for showing the different types of axes and database. So what these commands allow you to do is they allow you to very quickly turn on or off the display of all entities of a certain type, such as turning off the display of all domains. As you can imagine, that can really help out with decluttering an existing grid project. Now, for our next feature, I'd like to go ahead and move over into Pointwise. Now in Pointwise, you can see that we've got what is a generic brake assembly read in right now. What I wanted to show you is if I manipulate this brake assembly, in other words, if I pan it or if I rotate it, you'll notice that when I move my cursor, that it moves with my cursor. When I stop moving my cursor, it continues to move a little bit. We call this feature glide. So if you go look at the Edit Preferences panel in Pointwise, you'll see under Mouse Style that we now have a toggle available where you can turn glide on and off. So if you don't like this behavior, you can choose not to use it. So I'm going to go ahead and turn it off now just so you can see what the difference is. So with glide off, if I pan the exact same model, you can see that as I pan it, whenever I stop my cursor movement, the model stops exactly. It does not continue to move after the cursor has stopped. Now for my work, I enjoy using glide, so I'm going to turn it back on and then go ahead and close the Preferences panel. Now to move on to our next feature, I'd like to go ahead and put a surface mesh on this brake assembly. And this is actually pretty simple to do. There's just a couple of things that we need to do. The first thing is we need to go to the Defaults panel, and we need to make sure that we have a default connector dimension set. So what this does is whenever we create a mesh on this brake assembly, any new connectors created will have this dimension. And in this case, we're going to create an unstructured grid, so that means I'm going to set a default average spacing, which means that all new connectors will have an average spacing between grid points of 0.1 units. All right, so I'm happy with this, so let's go ahead and leave it alone. Now, I did say I'm going to make an unstructured surface mesh, so I need to make sure that I have unstructured selected in my toolbar. If I was making a structured surface mesh, I would toggle on the structured option. Now we're ready to make our mesh, so let's go ahead and select the brake assembly. Then go up to the Domains on Database Entities command. So this command will take whatever geometrical entities or database entities that you have selected. It will use the default connector dimension or average spacing. It will apply it to connectors created along the edges that you've got defined here in the assembly, and then create surface meshes or domains from those connectors. So let's go ahead and do that now. So I'm going to press the button, and Pointwise will go off and create a surface mesh for the brake assembly. Okay, so it's finished, but you'll notice that the display is actually a little bit cluttered because we can see the original brake assembly geometry as well as the mesh, so it's a little bit difficult to see. So I'd like to clean up the display a little bit. I can do that by going to View and Show Database. This is one of those commands that I spoke about earlier when we were looking at the new accelerators. So I can either turn off the display of database entities here in the View menu, or I could use the new hotkey, which for this option is Control-Shift-F5. So I'm going to turn it off. So that did help. I don't have the database in the way anymore, but the domains are in a wireframe mode, so it's still a little bit difficult to see them. So I'm going to select them and go up to our Display Attributes panel, or toolbar, and select a hidden line mode. So this will make only the frontmost portions of the grid visible. As you can see, that did help. It cleaned up the display, and now the grid is a lot easier to see. So let's go ahead and zoom in on the grid and take a closer look at it. So you can see here, looking at this area around the bracket, that what we have on the surface mesh are equilateral triangles. This surface mesh was created using a Delaunay algorithm. And Delaunay is known for creating nice equilateral triangles, but there is a certain amount of randomness in the positioning of the triangles in the domain. Now, the new feature that we have available in Pointwise version 17.1 is you now have two options for how your surface mesh is created. You can either use a Delaunay algorithm or an advancing front algorithm. There are two ways to use the advancing front algorithm. The first would be if you define that as your default algorithm for creating surface meshes. You would do that over here in the default panel underneath the unstructured domains and blocks option. So I'm going to select it, and you can see at the very top here there's our algorithm option, and if you click on the pull down you'll see Delaunay and advancing front. So if I selected advancing front here, then any new surface meshes or domains I created after this point would use advancing front. Note that changing this will not affect the surface mesh that we have already created. So this is not the technique for us converting the surface mesh we just made into an advancing front. So I'm going to go ahead and leave it alone. And I'm going to go show you how we can convert this surface mesh over to an advancing front. So the first thing we'll need to do is we'll need to select all of our domains and then go to Grid and Solve. Once we're in the Solve panel, you'll notice there are 4 tabs. We want to go to the Attributes tab, and you'll see our very first option here is for Algorithm. So let's change it from Delaunay to Advancing Front. Now, once you've changed it to Advancing Front, there's one more thing you need to do, which is reinitialize these domains with this algorithm. So click over to the Solve tab and just click Initialize. And Pointwise will go off and recalculate each domain based on that algorithm. All right, it's finished. So click OK to save the initialized domains. And now let's zoom in on that same area and look at the difference in the mesh. So as you can see, we still have nice equilateral triangles on our surface mesh. However, the behavior is a little bit different. With an advancing front technique, it creates these equilateral triangles and grows them off the boundary. So in other words, you're going to have layers of equilateral triangles off each of the boundaries. Now, as you can tell, it's a very pretty mesh. It's very pleasing to the eye, and it looks very structured and very regular. So now that we've got the surface mesh that we want, let's go ahead and zoom in and look at a couple of other things with this mesh. the next thing, actually, I think we want to do with this mesh is talk about a common problem that our users run into, which is they make a surface mesh such as this one, and after it's done, they find that they need to add some feature to the geometry. Let's say maybe you need to cut a hole in the geometry for maybe an inlet or an outlet, or maybe you need to add something like an antenna or a radar or a bracket to the geometry. But you already have an existing surface mesh that you're happy with, so you don't want to have to delete parts of your existing mesh just to add a new feature. So I'm going to go over two new features in 17.1 that will help you out when you need to add a feature to an existing mesh. The first one has to do with creating connectors on database boundaries. In the past, you could select a database surface in Pointwise, and if you had a default average spacing or dimensions set, you could use the connectors on database entities command, and it would create a connector on each edge of that surface. Well, oftentimes when you're adding a feature to a grid, you need to select just a few of a surface's edges, not all of them, and create connectors on them. And that's what you can now do with Pointwise. So before we have boundary edges that we can select, we need to create them. So what I'm going to do for this particular geometry is I'm going to add a hole right here that can act as an inlet or an outlet. To do that, I created a cylinder beforehand and I saved it in a layer that I had turned off. So let's go ahead and turn that layer on. Alright, so I turned the layer on, but you still don't see a cylinder in the display window. The reason for this is earlier I used the View Show Database command and turned off the display of all database entities. The cylinder that I created that I want to use to create this hole is a database entity. So I need to toggle this back on so I can see my original geometry, and I can also see the cylinder right here that I added. So let's go ahead and add this feature to the geometry. So I'm going to go and select the cylinder. There it is. Now, to add this to the geometry, I actually need to trim the brake assembly geometry with the cylinder I currently have selected. So I select the cylinder and go to the Edit Trim by Surfaces command. Then I select the brake assembly. So when I click the Imprint command, what will happen is Pointwise will take these two groups of database entities and trim them against each other. It will do so by creating first intersection curves, then use those intersection curves to figure out where the new trim surfaces should be. So go ahead and click Imprint and click OK to save our trim surfaces. Now that I've trimmed the brake assembly, I don't need the cylinder anymore, so let's go ahead and turn off that layer. And let's zoom in too. So as I zoom in, you can see where the cylinder intersected both the innermost surface of the brake assembly and the outermost. So I should have database boundaries here that I can select to create connectors on. So to do that, I need to come over and turn off the selection of database entities. This might seem counterintuitive, but we actually have a special selection mask that is just for picking boundary curves of database surfaces. So you don't have to have an explicit database curve there. You can have a surface and just pick one of its bounding edges, and it will use that as a curve for you to create connectors on. So turn that selection mask on, and then go select the two half circular boundaries that were created by that trimming operation. Now, because we still have a default average spacing set, I don't have to do anything here before I go up and use the Connectors on Database Entities command to create two connectors on this hole. Now that I've got the two connectors, I want to take a look at this domain. So I've got two connectors there, but the two connectors have not been integrated into my existing surface mesh yet. So that's our next step. To do that, I'll use our new Edit, Add, Remove Edges feature. So first I'll select the domain, then I'll go to Edit and Add, Remove Edges. Now, as soon as I enter the add remove edges command, you'll notice that it highlights the outer boundary of the existing domain that I selected in red, and it also puts directional arrows on it too. It also assumes that when you enter this command that you want to add edges to a domain. So you can start by clicking a connector on one of the edges that you want to add. So I'm going to click on this connector, and as soon as I do that, Pointwise goes ahead and selects the other half circle connector. The reason it does that is because we have autocomplete checked on. The autocomplete option, when you're creating a domain and assembling edges, when you select one connector, it will look to see if there are any connectors that touch that one that will form a closed loop of connectors. If it finds a closed loop, it will go ahead and select those connectors for you. And that's exactly what happened here. So let's go take a look at this edge. So currently I've got two connectors. They form one interior edge and they run in a clockwise direction. This is perfect because whenever I'm adding an inner edge to an unstructured domain, I need the direction of that internal edge to be counter to what the direction of the external edge is. So since this is counter, we're okay. If it was the same, I would have needed to use the flip edge orientation command to reverse the inner edge orientation. Since we're okay, let's go ahead and click Save Edge. It will highlight that inner edge in red as well to show it's now part of the existing domain. When we click OK, that will save the existing domain with the new configuration. And as you can see, the domain now has that feature in it, that hole that we wanted to add. Now, right now there's no mesh in the hole, so if you wanted to have a mesh inside that hole, you would need to select those two connectors and create a circular domain there as well that you could use for inflow or outflow. So let's move on to the next usage of that new command, which is defeaturing. So just as you can add an edge or a feature to a domain, sometimes you'll want to remove them from a domain. Now I want to use that on this domain right here, but as you can see, we've got the database and the grid on at the same time, and the display is a little cluttered or mottled. So let's go ahead and go back to View and turn off the display of database entities. Okay, so that's a lot easier to see now. So for this domain that I was pointing out on the bracket, you can see that there's a bolt hole in the domain right now. I don't really want to model this bolt hole for my simulation, so what I'd like to do is go in. I'm going to delete the two domains that are the interior of the bolt hole. And now I want to take this domain and use Edit, Add Remove Edges to defeature the domain. So as soon as I enter the command, you can see that my two edges are highlighted in red. Because Edit, Add, Remove Edges assumes that you want to add interior edges when you enter the command, you'll need to enter a removal mode to remove that bolt hole. And that's very simply done by clicking on Begin Removing Inner Edges. So as soon as I do that, all interior edges are highlighted as candidate edges for removal in this green color. We only have one edge, so that's our only option for removal. So I'm going to select it and then click End Removing Inner Edges and then OK. As soon as I click OK, the domain definition is updated to no longer have that interior hole, so it creates nice isotropic triangles as if that bolt hole did not exist. So we've effectively defeatured this part of our surface mesh, and you can see that that was actually quite easy to do. Now that we've defeatured our mesh the way we want, and ideally I would go around and perform the same procedure for the remainder of the bolt holes on this geometry. Now I want to look at some of the new distribute commands that we have available. So to do that, I'm going to go over here and turn on the selection of connectors. And I'm going to select the side connector on the bracket. And then go to Grid Distribute. Now once I enter Grid Distribute, you'll see that the connector is highlighted with white arrowheads on either side of the connector. These are the spacing constraints on either end of the connector, and you can see what their current setting is here in the actual frame in the table. Now, what I want to do is not change the current spacings. I actually want to sort of interrogate this connector and see what spacings are along the length of it. I'm going to do that by clicking on Probe, and as soon as I click on Probe, you notice those white arrowheads disappear because it understands this mode that I'm going into is interrogating all the points along the length of the connector. So let's start off by highlighting one grid point. As I move my cursor over one grid point, you'll see that it shows what the exact spacing is between that grid point and the one before it, and that grid point and the one after it. If I move my cursor to the space between two grid points, it will just show me the exact spacing at that location. So this can be very useful when you're trying to determine if you actually got the edge lengths that you were looking for along a connector. Now, once you're done using that command, you can simply go over here and uncheck Probe, and you'll go back to your normal mode in the Spacing tab of being ready to set spacings on your connector. Now, another thing that I usually like to do with connectors is I like to come over here to the Functions tab, and I like to use the Copy From command. The Copy From command allows me to take the distribution from one connector and copy it over to another. And in this case, I want to copy the distribution from this connector over to this one. So I'm going to go ahead and check on Copy From so we can talk about our next new feature. So it highlights the connector that I went into the command with in pink. That's the command that will take the new distribution. And it expects me to go ahead and select the connector or connectors that I want to copy a distribution from. So I'm going to select the connector opposite from it. And notice that it immediately highlights in yellow and also shows me a directional arrow. This is new for Pointwise 17.1 because it is important when you copy a distribution that you make sure that the two connectors have distributions that are in the same direction. So let's go ahead and check that now. So you can look at the original connector we entered the command with and see that the triangle is right here. The triangle is always the beginning of the distribution, and the square is at the end. That's always the end of the distribution. Now, looking at the connector we want to copy the distribution from, you can see that the arrowhead is over here, which means that the beginning is here and the ending is here. So they're actually opposite from each other, and it looks like we probably need to use the reverse command to reorient the connector we're copying from. So now if we copy a distribution from this connector to this connector, it'll be in the right direction. So let's go ahead and copy the delta values. They are moved over to the connector I entered distribute with, and I click OK to save the connector. So those are our new distribution commands. To show you our next new feature, I'd like to go ahead and move over to a new grid. So I'm going to go to File, and I'm going to go down to my most recently used file list and select sedan.pw. Pointwise will ask me if I want to save changes to the current grid. I do not in this case. It'll also ask if you want to replace the existing grid or just append to it. I want to replace it. So now it's going to clear all the tolerances, all the defaults, and then it's going to import this new grid and any settings that came with it. And as you can see, the new grid is actually a car in a wind tunnel. Now, for this particular grid, the thing that I would like to do is I would like to add more resolution behind the car in the wind tunnel. I can do that by adding baffle domains to the grid, which will give me some artificial clustering out behind the car and hopefully some improved resolution. The only problem is right now if you look at my block definition, and that's pretty easy to do just by selecting the block, you can see all of its boundaries highlighted in pink. There are no domains behind the car right now highlighted in pink. So let's go ahead and add some and see about adding them to the existing block as well. So I'm going to go over to Layers. Now, before this webinar, I went ahead and created the baffles that I want for the wake region and put them in this layer and turn them off. So I'm going to go ahead and turn that on now. Now, you can see my domains behind the car. These are going to be my baffle domains. And notice, if I get a side view, it'll be easier to see. When I select the block, they are not highlighted in pink, so they are definitely not part of the block definition at this point. To add them to the existing block, I can simply select the block and then go to Edit and Add Remove Faces. Now, the Add Remove Faces command is very similar to the Edit Add Remove Edges command that we looked at earlier. You can use it in the same way. And it also expects when you enter the command that you're going to be adding faces initially. And that's what we're going to be doing. So let's go ahead and let's zoom in on those baffle domains behind the car. And let's select them and add them to the block. So I'm going to do this just by using a Shift Select box around the domains. And as soon as I let go of the selection box, you'll see that the domains are now highlighted in white, and at the two ends of the domains there are two bold orange outlines. Those orange outlines indicate that the face I have selected to add to the block is open in two locations. Now, currently this is going to be considered a baffle face because it's open, and that's actually what I was planning on creating. If you were doing the same thing and you wanted this face to be added to the block but you wanted it to be closed, this would be an indication that you need to select more domains to close off those two regions. So let's go ahead and click on Save Baffle Face. And as soon as I do that, you can see that the baffle domains now have orange normal arrows pointing off both sides of each domain. So it's a part of the block definition now. If I hit OK, it is saved with the block definition, and whenever you select the block, you'll also see it highlighted. Now, it's important to note that whenever you're adding a face to a block, like we just did here, that the process of adding the face, it's not going to delete any of your block boundary conditions, but it will delete the interior cells in the block. So adding the face means you will have to reinitialize the block. And then after you've reinitialized it, you'll probably want to go and set boundary conditions on whatever face you added. But for the faces that existed before then, they're going to remember their solver boundary conditions. So you won't have to go back and redo that part. Now that we know how to add faces to a block, let's go ahead and move on and look at some of our new CAE solver features. So this list here has a lot of information on it, I know, and I'm going to go through it piece by piece. So as you can see, what we have here is a list of CAE solvers that are now available in Pointwise 17.1. Now, some of these solvers are new. Some of them have been in Pointwise 17 before, but they were updated for 17.1. So the first update that we want to look at involves the CAE solvers that you see with an asterisk to the right of their name, such as AccuSim, AccuSolve, ANSYS CFX, ANSYS Fluent. For these CAE solvers in 17.1, you can now turn on the ability to combine anisotropic tetrahedra into prisms during export. If you create T-Rex meshes and you use these solvers, this is going to be a very powerful feature. This ability to combine anisotetrahedra into prisms can yield up to a 66% cell count reduction for your grid. So I encourage you, if you're using these solvers, to please try out this feature and see how it works for you. And as you can see, there's at least, I think, 16 solvers here that now support this feature. Now, the next thing I wanted to look at are the solvers that you see with a dagger to the right of their name. So in this list, we have Wind Unstructured and Wind Structured with a dagger to the right of their name. There are two CAE solvers not shown in this list, which are Inca and Impark. These four solvers all now support the ability to set attributes for the solver before you export your grid file, and those attributes will be written out with the grid file. Now, for the 4 solvers that I'm talking about, they just have one attribute that people were interested in, which was the ability to set units for that solver. Now, this ability to set attributes for the solver before you export files is not going to be restricted just to these 4 CAE solvers. We are open and willing to add attributes to any of the solvers that we support. We just need to know which solvers customers will be interested in having this ability for, and which attributes you would like added. So if you are interested in doing this for your solver, please contact us and let us know what you would like to see. Now, the last thing I wanted to look at on this slide are the 2 solvers that you see with a double dagger to the right of them. Those are ANSYS Fluent and Cobalt. These 2 solvers take advantage of some new data functions that we have in Pointwise version 17.1. In the past, you could write a plugin for Pointwise for a face-based solver. And if you're not familiar with the term plugin, which I know you see a good bit on this slide, a plugin is essentially a method you can use to write an exporter for your solver for Pointwise. So if you have an in-house solver and you'd like your grid written out in its format, you can write a plugin so that it's integrated with Pointwise natively, and you can do that just in one step. It's really nice being able to cut out converters where you export in one format and then have to convert to the format you actually really wanted. So getting back to my point, we have these new data functions. So in the past, you could make a plugin for a face-based solver, but you would have to go through some extra effort to do so, some extra coding. And they did have some issues with memory efficiency. So what we've done is we have updated our plugin SDK to contain new face-based data functions. So it's much easier to write a plugin for a face-based solver such as Fluent and Cobalt. And both of these have been updated with the new data functions. And in addition, these new data functions also help face-based solvers have increased memory efficiency for writing out files. So this is a strong feature that I heavily encourage you to try out for your own face-based solver if you're interested in writing a plugin for Pointwise. Now, our last new feature, I don't have a slide for, but it's something we did in the last couple of months. We rewrote the Pointwise native file format. For those of you that are using Pointwise currently, you know this as the project file or the .pw file. So what we are interested in doing is trying to improve the read and write times for the Pointwise project files. We are especially interested in doing this just from the aspect of our customers are generating larger and larger grids, and we don't want the bottleneck to be import or export of a Pointwise file. So we rewrote this file format, and we have found from our testing that with the new file format in 17.1 that you could have up to 100 times faster project file open and save times in Pointwise. So that kind of improvement in read and write time is significant, especially when you're working with very large grids. You might see an increase in file size. We have seen that file size can increase up to about 2 or 3 times with this new file format, but we definitely think that's worth it for that kind of increase in speed. Now, those are all the new features that we currently have available in Pointwise version 17.1. We really appreciate you attending our webinar this afternoon, and the recorded video of the webinar will be available on our website tomorrow, the 22nd of February, at www.pointwise.com/webinar. If you have questions after the webinar about Pointwise, please feel free to email us at webinar@pointwise.com. And the last thing, especially don't forget to join us at the Pointwise User Group meeting on the 19th to the 20th of March. If you're interested in more details about it or to register, you can go to www.pointwise.com/UGM. Now, we're going to open up the floor for questions. If you have any, please type them in the questions box, and Eric Gant will be happy to help you.
Thank you, Carolyn. It appears right now we don't have any questions, so our attendees are trying to make it easy for me this afternoon. Does anybody have any last questions to ask before we sign off our webinar? Yep. Okay, looks like we have a question here. Let me open this up. So old project to new project file conversion. Project file or native file conversion happens automatically. So there isn't anything manual that's necessary for users to do. Basically, as soon as you begin using the new version of Pointwise, as soon as you save a file or a project native file from the new version, it's automatically written out into the new format, whereas it can still read in the previous format from the previous versions of Pointwise. So that's all handled automatically and is very seamless for you. The next question has to do with being able to sort entities, specifically being able to sort entities by boundary condition type. And I know that's an item that we've had in our wish list for a pretty good while now. We are hoping to get that capability integrated into the list tab of our panels in the interface, where you can see entities listed by various types of information, their type specifically, the number of points and cells for blocks and domains, for instance. And so we do want to add that capability into the list. It just has not made it into the code yet. Fortunately, now that version 17 has been released, we have a lot more opportunity to look at user convenience features of that kind. So hopefully we will see that before too long. Okay, let's see. We have some more questions coming in. Let's see. Old Pointwise is, can Pointwise, the older versions or previous versions, import a new project file? And unfortunately, they cannot. Older versions of Pointwise, unfortunately, don't know anything about the new file format. So it's not possible for the older versions to import those new formatted project files. So obviously, once you have started using version 17, you're committed to staying with version 17 in the project files. Let's see. I think that looks like most of our questions. We have one more here. The next question is are we going to implement an advancing front capability for our blocks? So right now, as Carolyn demonstrated for you earlier, we have implemented this new capability at the domain level where you can use the advancing front method to initialize your unstructured domains. The question is we're going to add that to the blocks, the block solver. Actually, I think we do have in our list of items to add to the block solver for unstructured grids the ability to perform an advancing front initialization of isotropic tets for volume grids. That's something that's a little bit further down the road for us right now, but I do know that it's been discussed here and that we hope to add that type of capability in the future. We have another question about the file format along the same vein of transferring files from one version to the other, and can the new version of Pointwise export the old format project file? And unfortunately, we have not implemented that capability. It's not possible to export the older format of a project file from the new version. And let's see, one last question it looks like. The question is, if you can't transfer the newer project files to older versions of Pointwise, can you use GridGen as a workaround to do that? There may be some limited ability to do that. However, generally, whenever we release a new file format for Pointwise, we also simultaneously release a new version of GridGen so that the two software packages can communicate with each other with the latest file format. And if you'll recall, Pointwise is actually the package between the two that reads in the other's files. So when you're transferring data back and forth, Pointwise will read in GridGen's files and it will write GridGen's files, .gg and DBA files. But it does not transfer project files into GridGen. GridGen cannot read project files. Maybe I misunderstood that question. The user is asking specifically if you could just use the GridGen format and then re-import that into Pointwise. So that's actually a good question. Writing out .gg files and DBA files from Pointwise, the newest version, to GridGen and DBA files, those files possibly could be imported into the previous version of Pointwise. I don't recall at this point when exactly we updated GridGen's format. We would have to look into that and see specifically when the format was updated and whether or not you would be able to take that path to get to the previous version of Pointwise. It may be possible. Okay. Lots of format questions this afternoon, but I think it looks like we have covered all of the questions. Does anybody have any remaining questions before we sign off the webinar? Okay, well, if that's all the questions, I'll just reiterate these items that Carolyn has on her last slide here. Again, of course, thank you for attending and giving us your time this afternoon. The webinar will be posted tomorrow at the URL that's listed there on the slide. Definitely let us know if you think of any more questions after we sign off, and you can send webinar-related questions directly to webinar@pointwise.com. And one more additional plug for our user group meeting next month. Please do give it some serious consideration. We will have some user group meeting specific training available for a day that will be very useful, just particularly for people doing structured meshes. We have a lot of structured gridding covered in that training. Of course, we'll have a day full of very interesting presentations by our users. And as always, we always serve very excellent food at our UGM, so you definitely want to give it some thought. And that's it for this afternoon. Thank you all for attending, and we hope to see you again at the next webinar.